We measure atmospheric ozone, water vapor, two greenhouse gases, methane and nitrous oxide. We also measure hydrogen and a minor greenhouse gas called sulfur hexafluoride. The purpose is to monitor the trends with time and their distributions. They are mainly destroyed in the upper atmosphere, the stratosphere, so we would like to observe where they're destroyed. We sample the air by bringing it in to the instrument. This is the inlet for the water and the gas chromatograph. This is the inlet for ozone. We have the inlet face backwards because we're measuring water vapor. We do not want to get ice crystals into the instrument. So that's why it's curved this way. In the back, we have the analytical instrument with its own computer. To bring the air from the outside, we have a large pump, compression pump here. To run the gas chromatograph, we have, in this bottle, nitrogen carrier gas. And we also have, in the orange bottle, a standard. So it's an analytical instrument where we have to run a standard and an unknown, and then we put a number on it. How we get a number for the gas that we're observing is we suck in air, put it into the gas chromatograph, we get a signal. Then we run the orange bottle, the gas in the orange bottle, which is a calibrated standard, through the same analyzer, compare it. The calibration is linear, so we just can get a very direct measure of that gas through a simple formula. And that gives us the concentration of the greenhouse gas in the outside.
Easy left.
The purpose of this mission is to measure water vapor. Water vapor is an important atmospheric feedback gas. It is influenced by the growth of climate gases in the atmosphere, the growth of CO2, nitrous oxide, and methane. Nitrous oxide and methane are measured by this instrument, along with water. If greenhouse gases warm the atmosphere, we could have more clouds. More clouds would mean more cover and would cool the Earth. However, if the water vapor evaporates and stays in the atmosphere, doesn't form clouds, it's going to warm the atmosphere. So it can go either way. It can either be a cooling gas or a warming gas, and that's why it's referred to as a feedback gas. We would like to understand how water vapor responds to climate change and what effects water vapor may have on ozone.
NASA 872. NASA 872.